Okay, now let's look at question 4a, practice 4a, question 6. Okay, question 6, you're given two squares here. Alright, you're told that ABCD is a square and PQRS is a square as well. So, okay, sorry, I missed out a line here. Okay, so we know that if this is a square, we know that these are also, okay, right angles. Let me just draw them in. And you are asked to find triangles. First of all, let's look at the first triangle. You're asked to find triangle that is congruent to QBR. Okay, so we want to find a triangle that is congruent to QBR. Alright, let's look over here. Okay, can we find a triangle that is congruent to QBR? Now, can you imagine QBR, okay, if you rotate it, okay, you can see that it actually becomes this triangle here, but you have to do some kind of a rotation where B actually corresponds to the right angle A, and you find that BQ corresponds to AP, and then BR actually corresponds to AQ. Okay, but how are we going to do that? Well, you know that whenever you see a right angle triangle, okay, first thing you want to see is if you can use RHS. Okay, so let's try. Our hypothesis is that triangle, okay, QBR is congruent to triangle, okay, PAQ. Okay, where angle B corresponds to angle A, and then AP corresponds to BQ. Okay, so let's see whether we can prove this. Alright, first of all, okay, if I want to use the RHS, I can prove the right angle. I know that angle QBR is actually equals to angle PAQ is equals to 90 degrees, right? This is given to us and this is our R. Now, how do we prove that the hypotenuse is the same? Well, we know that the hypotenuse over this side, okay, let's look at this triangle QR. QR is equals to, okay, square root of, okay, QB square plus BR square, right? And we know that this is also equals to square root of, well, QB I know is equals to AP. So I can replace QB square with AP square. And BR I know is the same as AQ, okay, as given in the question. So I can replace BR with AQ square. And we know that square root of AP square plus AQ square, this also gives you PQ. Therefore, we show that QR is equals to PQ. Okay, and this gives you the H, which is the hypotenuse. And finally, to show our last side S, okay, we can just show that, for instance, if we take QB, then QB is equals to, okay, look at this side here, PA. The order is important, not AP but PA. And this is our last side. So we can show that triangle QBR is congruent to triangle PAQ by the RHS method. Okay, and this is shown. Okay, so then now let's look at the second part. The second part, we are then asked to find a triangle that is congruent to triangle PQS. So PQS is this triangle here. Well, I hope you can see easily that PQS, okay, will be congruent this other triangle here. Now, how do we prove that? Okay, you have to look back at the question again. Remember, they say PQRS is a square. So if it's a square, I know that the four sides here are equal. And of course, this is a common side here, okay? So we know that QS here, okay, of both sides must be equal. See a right angle, we can again use the RHS very quickly. Okay, so let's label this as part B, even though there's no part B given. Okay, so I want to say that triangle PQS is congruent to triangle, okay, RQS, and we hypothesize that it is due to RHS. Okay, let's show very quickly. Angle PQS, we can show, sorry, not PQS, we're trying to show the right angle. So the right angle is actually QPS is equals to angle, okay, QRS equals to 90 degrees. Okay, this is my R. Okay, my hypotenuse QS is equals to QS. Alright, because it's a common side. So this is your hypotenuse. And then your last side, you can choose any side, okay? If I choose PS, PS is actually equals to, okay, RS, right? Because they are all sides of the square. And this gives you the S that you need for the RHS. Therefore, we can prove that triangle PQS is congruent to triangle RQS. Okay, so I hope you have got this question correct.